Hello, in this problem we will talk about the 8 coder beginner contest 214 number D problem, which is sum of maximum weights. I suggest you to read the problem. If you haven't read the problem, so I will first I will make sure what the problem is stating, and then I will go to the solutions, right? So the problem is stating that you have a tree, and each tree, there are some vertices, and the vertices are connected, and the connection has some weights, right? So here 1 and 2 is connected and the weight is 1. Here 2 and 3 is connected and the weight is 2. Here 4 and 2 is connected and the weight is 5. Here 3 and 5 is connected and the weight is 40. So what you have to do here is just, if we take the test case, we get 1 to 2 and it is connected with a weight of 1. 2 to 3 it is 2. Then we get a 4 to 2 we get a 5. So 4 to 2 we get a 5. Then 3 to 5 we get 14. So what you have to print here is, from 1 you can only go to the vertices which are higher than 1. So from 1 you can go to 2, from 1 you can go to 3, from 1 you can go to 4, from 1 you can go to 5. So from 1 you can go to these vertices, right? So what you have to do here is, you have to print the along the path, you have to print the value of, you have to add the value of the maximum age, right? Suppose this is our answer. So if we go from 1 to 2, the value of the maximum age is 1, so we will take 1. If you go to 1 to 3, the value of ages are 1 and 2, because from 1 to 2 then we will go 2 to 3, so there will be two ages. So the value of the maximum age is 2, so we will add 2. Now we will go from 1 to 4. So from, if you want to go from 1 to 4, the the path will be 1 to 2, then 2 to 4. So 1 to 2 has a value of 1, and 2 to 4 has a value of 5. So the maximum value is 5, so we will add 5 here. So like this we have to go on. So from 1 to 5 the maximum value is 14, so we will add 14. Now it is, now we will go to 2. From 2 you can't go to 1, because 1 is smaller than 2. From 2 you can go to 3, 4 and 5. So from 2 to 3 the maximum value is 2, from 2 to 4 the maximum value is 5, from 2 to 5 the maximum value is 14 again, right? So now we will go to 3. From 3 to 4 the maximum value is 5, from 3 to 5 the maximum value is 14. So that's it. Then we will go to 4. From 4 we can only go to 5, and from 4 to 5 the maximum value is 14, so we will answer 14. We will input 14, right? So the total number of, yeah, so the summation is, there are 4 14s, so the 4 14s will get us a 56, and there are 3 5s will get us a 15, and there is 2 2 and 1, so there is another 5, so we will get an answer of 76. So what you will have to print here. So how we can solve this problem, right? So uh, what we will have to do here is, first we have to sort the edges, right? So the edges here are 1 2 5 and 14. So it is pretty good here because the edges are already sorted. So first you have to take the edges and sort this, right? Then you will take the first edge, right? The first edge is one, edge is 1, right? So first edge is connecting 1 and 2. So 1 and 2 is connected by 1, right? So 1 and 2 is connected by 1, right? So that's it. So 1. Now what we will do, we will make 1 as a parent of 2. 1 as a parent of 2, right? 1 is a parent of 2. You can also make 2 as a parent of 1. It's all your wish, but I am making 1 as a parent of 2, right? So that's it. So now what's happening here, then we will go to the second vertex, right? And the second vertex is 2 and is connecting 2 and 3, right? So what's happening here? So 2 is a child, right? So what's happening here is, 2 and 3 are getting connected, right? 2 or 3 are getting connected. So recognize this, as 2 is connected to 3, as 2 is connected to 3, 3 is also connected to 1, right? 3 is also connected to 1. So what are the total number of new connections we are getting? The new connections are 2 and 3, 1 and 3. From 1 to 3, 2 to 3. 1 to 2 is not a new connection, because 1 to 2 is previous connection before 3 coming in. So 1 to 2 was a previous connection. 2 3 and 1 3 are the new connections. So the number of new connections are 2, right? And both of these new connections will go through this path, right? Because this path is creating the new connections. So all the new connections will go through this path, and this path is the max, this and the value of this path is the maximum up to now, right? Because we have sorted, so 2 is maximum than 1, we already know because it is a sorted, right? So these two paths will have a value of 2. So 2 into 2 will get a value of 4, right? So as we have sorted the edges, each of the time a new path is created, we have to find out how many new paths are created. And if we can find out that these many new paths are created, we have to just multiply the number of new paths into the value of the edge, right? Because each of the new path will have the value, we will have the value of this edge, right? Because each of the new path will go through this edge, right? So how we can find the number of new paths? So it's a if you have known about union find algorithm, you might know this. But if you don't, I will make you understand this. Suppose there are some connected graph here, and there are some connected graph here, right? Okay, so this is the parent of this graph, and they are their children, right? And this is the parent of this, and they are their children, right? So suppose, so this parent has got how many children? This parent has got itself, so one. He has got this one, so another children. He has got this one, so another children. So this parent has got total three number of children, right? And this parent has got how many children? This parent has got itself one, and there another children one. So this, the total number of vertices here are two, right? So there are two. So as so we will store three in this one, indicating that this parent has got three children. We will store two, we will store two in this one, indicating that this parent has got two children, right? So as we are connecting C and C, suppose we are connecting this C and this C, these children and these children. First of all, we have to know what is the parent of this children. So we will, is this the parent of children? No, this is not the parent of children. Is this the parent of these children? No, this is not the parent of these children. Is this the parent of children? Yes, it is the parent of children. So then we will see how many children this parent has got. So this parent has got three children, right? So now come to this. Is this the parent of itself? No, it's not the parent of itself. Is this the parent of itself? Yes, this vertex is the parent of itself. Now we will see how many children these vertex has. So this parent has two children. So as C is connected to this C, all the children here are also connected to all the children here, right? So each of the children here are getting connected to each of the children here, right? So what are the total number of connections? The total number of connections equals to 3 into 2, because each of the three children here are getting connected to each of the three vertices here, right? Each of the three vertices here. So the number of connection is, the total number of connections is 6. So that's how we will find the total number of connections, right? So that's how we will solve the problem. So let's get into the implementation part. So we will take two arrays. One array we will take parents, and another array we will take ages, right? Suppose the parents array will have a length of the vertices, the ages array will have the length of the same, 3 4 5, 1 2 3 4 5. Okay, So what are the ages? 1 2 4 and 15. So 1 is connected to which? One is first we will take 1, and 1 is connected to, one is connected. So okay, so we will initialize this parents array with -1, indicating that each of the vertex is the parent of itself. -1 indicates that it is the parent of itself, right? -1 indicates that it is the parent of itself. So 1 is the parent of itself, 2 is the parent of itself, 3 is the parent of itself, 4 is the parent of itself, 5 is the parent of itself, because we haven't made any connections here, right? So we will take the first edge, and we will take what are the vertices that are connected through first edge. So 1 and 2 are connected through this edge, right? So what we will do, here, so 1 and 2 the are the vertices, right? So we will make the parent of, we will find out the parent of 1, we will find out the parent of 2, and we will initialize these with 0, because, so we will initialize this with 1, right? We'll initialize this as 1, because as we haven't made any connections yet, each of the vertex will have only one children, which is itself. 1 has only one children, which is itself. 2 has only one children, which is itself. 3 has only one children, so each of the vertices will have one, right? So first our vertices are 1 and 2, so we will find the parents of 1 and 2. So we will go to the parent array. So what is so the value of 1 is -1. So -1 itself, so 1 itself is the parent of itself. So the parent of 1 is 1, the value of 2 is -1, the parent of 2 is 2 itself, right? Now we will go to the ages. The children 1 got 1, the number of children 3 has got also 1, right? So what are the total number of paths? Each of the children will be connected to the each of the children, right? So the total number of path is equal to 1 into 1. So total number of 1 path, and each of the path will have this value. What is the value? 1. So the value is 1 into 1, which is 1, right? Okay, now we can see that 1 has 1 children, and so sorry, it's not 3, it's actually 2. So we have to go to the 2. 2 has 1 children, so both of them have same number of children, right? So the logic is, if one has smaller number of children, we'll make that one as a child, right? Here both have the same children, so you can make either two as a children of one, or can make one as a children of two. So we were making here two as a children of one. We are making one as the parent, right? So we will make two as a children of one. So what will become the parent of two? So the parent of 2 becomes 1. It's your wish. You can make 1 as a children and 2 as a parent. I am making 1 as a one. I am making 1 as a parent and 2 as a children. So you will write the name of the parent here. So 2 has a new parent now, and the parent is 1. So 1 itself is the parent, and 1 itself is the parent. So this is -1, and 2 has a parent, so it is 1, right? Okay. So as as now 1 has got a child which is 2, 1 has got a child which is 2. So the number of children 1 has now is not 1, but the number of children 1 has now is 2, because 1 has now 1 and 2. So 1 has now 2 children, right? So we will have to update this. So let's go to the next age, then you will clearly understand. The next stage is next age is 2, right? So the corresponding vertices of these two, the corresponding vertices are 2 and 3, right? 2 and 3. So we will again go to this parent array. So we have to find the parent of 2, the parent of 3. The 3 contains -1, so 3 itself is the parent of 3. 2 doesn't contain -1, 2 contains 1, so 2 has a parent. 2 contains 1, go to 1. 1 contains -1, so 1 is the ultimate parent of 2, right? So the parent of 2 is 1. Now go to the ages array. Now 1 has got how many children? 1 has got 2 children. 3 has got how many children? 3 has got 1 children only, right? So each of the children of 1 will be connected to each of the children of 3. So the total number of connections will be 2 into 1 2 into 1, so there are two connections, and each of the connections will have a value of 2. Each of the connections will have a value 2, right? So we will get a 2 into 2, so we will get a 4. Now 3 has one children, 1 has two children, 1 has got more children than 3, right? So what we will do here, we will make 3 as a child of 1. As 1 has got more children and 3 has got less children, what we will do here is we will make 3 as a children of 1, right? So as 3 as a children of 1, so we will write the name of the parent of the 3. The parent of 3 is 1, and 1, as 1 has got all the children's 3 has got, so the number of children now 1 will have is not 2, but 2 plus 1, there will be 3 children 1 has got. In the picture you want to see that as 3 is connected, as 3 is connected as 3 is connected to as 3 is connected to 2. Suppose you want to connect 3 and 2, so total number of connections how many will be there? So there are two vertices here and there are one vertices here. Each of the two will be connected to each of these, each of the vertex here, right? So there are two, there are one, so the number of connections will be 2 into 1, so there are two connections and each will go through this path. Each of the new connections will go through this path, and this path is 2, right? So it will be 2 into 2 equals to 4, and we will make now 3 as a parent of as a children of 1, right? So we have made this connection, right? Okay, so now let's get into the number 4. So as we get to the number 4, the corresponding vertices are 4 and 2. Sorry, it is 5. It is 5. So it is 5, sorry. So it will be 5 and it will be 14. Okay, so as we go to 5, the vertices are 4 and 2. So we will go to the 5 and the vertices are 4 and 2. So we will again have to find the parents. What is the parent of 4? 4 contains minus 1, so 4 itself is the parents of itself. So what is the parent of 2? 2 doesn't contain minus 1, 2 contain 1. Go to 1, 1 contains minus 1. So 1 is the ultimate parent of 2. So we will get a parent of 2 is equal to 1. Now go to the children ages array. 1 has got how many children? 3 children. 4 has got how many children? 1 children. So what will be the number of connection? Each of the children in 1 will be connected each of the children in 4. So the total number of connections equals to will be 3 into 3. There are, sorry, 3 into 1, because 4 has got 1 children only. So 3 into 1, there will be 3 connections, and each of the 3 connections will have a value of, we'll have a value of what? We'll have a value of 5. So we'll get a 15. So now we will compare the children. As 1 has got 3 children, 4 has got 1 children. The number of children 1 has got is greater than 4. So there is no them. So there is no reason to make 4 a parent now, because 4 has got less children. So what we will do, we will make 4 as a child of 1, as 4 has got less children. So what we will do here, we will input here 1, because now 4 has got a new parent 1, and 1 has now another children, and these children will be 4, right? So what is in the picture? In the picture 2 is connected to 4. As 2 is connected to 4, 3 and 1 are also connected to 4. So each of these 3 is connected to 4. The number of connections will be 3 into 1, and each of the connections will go through this path, and this path contains 5, which is greater than previous all other values. So the answer will be 3 into 5. And now what will, as we have made the connection, we will make 4 as a children of 1. Now 1 has got how many children? 1 itself, 2, 3, 4. So 1 has got 4 children, right? So now what we will do, we will go to the 14, the value of age, which is 14, and the vertices are 3 and 5, right? So we will connect 3 and 5. Find the parent of 3. Is 3 a parent? No, because 3 contains 1. 3 doesn't contain minus 1. 3 contains 1. Go to 1. Is 1 a parent? Yes, 1 a parent. So the ultimate parent of 3 is 1. Is 5 a parent? Yes, 5 a parent, because 5 contains minus 1. Whichever contains minus 1 is the parent. So 5. So go to now ages. 1 has got 4 children. 5 has got how many children? 5 has got one children, so each of the children of 1 will be connected to 5. So the total number of connections will be how many? There will be total number of connections 4 into 1 connections. So there will be 4 into 1 connections, total number of 4 connections, and each of the 4 connections will have a value of what? 14. So this will be 4 into 14, what will get? A 56. And if we add this up, we will get a 76, right? So now what is happening here? In the picture the thing is happening that 3 is connected to 5. Now as 3 will be connected to 5, as 3 is we will go to the parent of 3. So we will get a parent of 3, so the parent of 3 is 1, so we will go to 1. We will see how many children 1 has. We have seen that 1 has 4 children, and each of the 4, I mean this, each of the 4 vertices will be connected to 5. As 3 is connected to 5, each of the 4 vertices will be connected to 5. So the number of total paths will be 4 into 1. So there are 4 paths, and in these 4 paths, each of the path will go through this path, and this path is the maximum of all, of among other paths, because we have sorted the edges. So the value will be 4 into 14, and it will be 56. So now what's happening here? 5 5, how many children 5 got? 5 has got one children. How many children 1 has got? 1 has got 4 children. So as 5 has got less children than 1, so 1 is the greater parent than 5, right? So what we'll make, we will make 5 as a children of 1. So we will make 5 as a children of 1. And as 1 has got another children, so we will update, because 1 now doesn't have 4 children, 1 now have 5 children. So that's how you are going to solve this problem. Take a parent array, take an age array, and initialize the array with -1, and initialize the ages with 1, and then each of the time you are connecting an age, first sorted the ages, and each of the time you are connecting an age, update the ages and parents array, and update your answer. So that, take a variable and add this. So by doing this, you can solve this problem. Thank you.